for us to talk about. Yeah, thank you. Thank you, sir. So we have mass, we have length, MLT. We have time. What's the next one, brethren? I know all of us are physics students. At least before now, you must have done one or two things in physics. So after time, what's the next one? We should have temperature, right?
Electric current.
Good. We should have temperature. We should have electric current. What again? We should have amount of substance. Is that not so? Good.
Yes.
What's the next one?
Luminous intensity.
Yeah, we should have luminous. Hope I can spell that luminous. Luminous intensity. Is that the spelling? It's not correct.
LU.
LU, right?
Yes.
English students are, don't catch me. LU, right? Luminous, yes. Luminous intensity. All right, so mass, they have the unit associated with them, right? So mass is measured in kilogram, right? So we'll have our kg. We'll have the length, which is meter. We'll have the time, which is seconds. We'll have temperature, which is measured in Kelvin. I know there are other units of temperature, but then we'll specialize or we'll actually take Kelvin to be the basics. Is that okay? Then the next one is electric current, which is measured in ampere. Then we'll have amount of substance measured in mole. Then this young man, the last one, measured in candela. Measured in candela. Does that make sense? So these are the fundamental quantities. This is where everything revolves around in physics. Every other thing actually comes out from, everything comes out from what? From the fundamental quantities. Does that make sense? Does that make sense? So now we now have the derived quantities, which are actually coming from the fundamental quantities. It's going to be a quick one. But before that, these three guys are the key guys in, as long as physics is concerned, these guys are the key guys, right? Where you start seeing something like MLT, which we use for your fundamental, your dimensioning. When you start doing dimensions, MLT. So those guys are the key guys in terms of your fundamental quantities. Where M represents your mass, L represents your length, and T represents your time. So we're going to be making reference to those three guys when it comes to what your dimensioning, when it comes to dimensions in physics. When it comes to dimension, these are the guys we make reference to when it comes to dimension. So I'm going to come back to that later on. So the next one is your derived quantities. Are we together, guys? Later on, I'm going to send this, hopefully I'm going to send this slide to us. So now we'll have the derived quantities, as many as possible that you can mention. So derived quantities, very quick one. We're not going to take so much time on this. So for your derived quantities, we should have as many as you can list. We can have area, we can have volume, you can have velocity and speed, because somehow, yeah, I didn't hear you. Go ahead. You said density. God bless you. Yeah, thank you. Acceleration, density. What again? Density, impulse, power. Good. We have impulse. We have power. We have pressure.
We have energy.
We have what?
We have frequency.
I didn't hear what you said. Frequency. Who is saying frequency? Susan?
Yes.
Okay.
Yes, sir.
Momentum. Susan said frequency. Right. As then there's another one we're forgetting, which is very important. Very interesting guy. How can we mention all of these things and neglect force? We can't neglect force. Force is very key, and we cannot neglect work as well. How dare we neglect these key guys? We can't neglect them now. They are very important. So now your assignment one. Your first assignment for today I want you to go and find the formulas for all of these quantities. Find the formulas and let it register in your head. I can remember all of those formulas. It's very important as long as you're doing physics. Unlike outside there they give them formula sheets. But Nigeria is Nigeria. They want you to cram, right? So outside there, nobody wants you to start learning all these formulas and have it offhand. But because we are here, it's an advantage. So your assignment one is to go and practice, get the formula for all of these quantities.
So I think derivation of the derived meaning.
Yes, that's when you learn the formula, that's what you can now do derivations for the dimensioning. I'm going to, that should be towards the end of the class, I'm going to do derivation, which is the fundamental, that's dimension formulas. But I want you to know the formula before I'll be able to derive that. So now get the formulas for the following quantities. For the quantities listed. Yeah, so I leave it up to us to go find those formulas. Is that okay? So get the formulas for the quantities listed. Are we on the same page? Can we proceed? That's your assignment: area, volume, density, power, and the rest of them. Ensure you get those the formulas associated with them, and know where they are obtained from. Like example, let me just give you a heads up. For example, area is length times length. Is that okay? Area here is length times length, which simply means it is coming from what? The first guy, which is your length. Volume is L times L times L, which is 3, right? Volume here is L times L times L, which is L cubed. I want to go ahead and find the remaining, right? And then I'm going to bring back when it comes to dimension. I'm going to talk about that much later. Does that make sense, guys? All right, so that's the first part of the lesson, and it's part of the videos I sent to you. Any questions so far? Any questions so far? All right, so let's proceed to units and dimensions. Sorry. All right, so the next one should be on units and dimensions. So let's quickly look at your units and your dimensions and see what we can make out of it. So now we have units and measurements actually. Okay, in physics, there are key things that we measure. I will listen in now. Like I said, I want to do it in a way that I will still send the notes to us so that it's easier for us to actually read through. So now there are key things we measure in physics, right? We measure time, right? You measure time, you measure length, right? Time, length. The next thing you measure as well is mass, and you also measure weight. These are the 4 key quantities that we measure in physics. However, I'm going to pay attention to 2 key quantities. I'm going to pay attention to length, and I'm going to pay attention to mass and weight. Then the remaining 2 will be your assignment. You go and check how do we measure time and how do we measure the volume of a substance in physics. So like I said, my major focus is going to be on length, which is the major focus for JAM. It has more questions on it. And then the next one will be on mass and weight. The remaining 2 is left for you. They can ask questions on volume, but on rare occasions will you see that. So I'm leaving that to us. So now these are the key measurements in physics. So right, the first one I spoke about is the length, and length is a sure bet, right? So measurements in length. Measurements in length. Measurements. Measurements. Measurement of mass. having mass slash the weight. Under this measurement of mass and weight, that's where they start asking you what's the difference between mass and weight. If you can remember, they start asking you what's the difference between mass and weight. It's under this place that you get to find some of those things. So the next one is measurement of volume. The next one is measurement of time. Now, but our major focus so this is our focus for our class. So this is the major focus. Are we together now? So I'm focusing on what? Measurement of length and measurement of what? Of mass and weight. So let's quickly look at measurement. Is it in or off English? I think I should start going for English class. I should sign up for English lessons. So this is measurement of length. All right. So let's quickly focus on the measurement of length and look at the key things we are going to pay attention to, right? So remember your assignment. The assignment I gave was to do what? The assignment I gave was to do what? To check out for what? The measurement of what? Of length and time. So your assignment 2. You see how I'm highlighting all these assignments. Assignment number 2, because of those that will deny me, people like Emeso. Assignment number 2 says measurement of length. Measurement of volume / time. Right? Check it out. Okay, so let's proceed with measurement of length. So under measurement of length, I'm going to consider what we call precision and accuracy. What did I say? I'm going to consider what? Precision, and I'm going to consider accuracy as well. What we mean by reading accuracies. And we'll look at the 3 key instruments we use in measurement. There are 3 key instruments that we use in measurement. The number 1 instrument is your meter rule, right? That one we'll call ruler back in school. The one they call ruler, right? Meter rule. Then we'll look at your vernier caliper, and then we'll look at micro screw gauge, right? So these are the key 3 measuring devices we're going to be looking at and how we can measure them. Through the class, you see how you can measure using your vernier caliper, how you can measure using your micro screw gauge. And you cannot actually remember, these are some of the questions that Jambo always asks you how to measure those things. During my own time, I crammed it. I crammed how to read that. So that's how I entered the hall back then and answered those questions. I didn't really understand the concept of measurement for vernier calipers, but I studied the questions and I had to cram. But today, at least you have someone that will break it down for you to understand. So you don't cram just like I did back then. So number 1, I'm going to look at precision. I'm going to look at precision / reading accuracy. Then the second one, I'm going to look at your meter rule. The third one, I'm going to look at, what do you call it? I'm going to look at your vernier caliper. Vernier caliper. Is it double L or 1 R? You consider that on yourself. So the next one is micro screw gauge. Right? So, and I said something that these are the 3 key instruments for measurements. And see, another key thing you can do so that you can be active in class, so that you look as if you're in class, is not just watching this thing like Nigeria movie. You can have your short notes where you're writing down something. If you know you have your notes, can you just reply by raising your hands up? There's a raise hand button there. Or if you know you're watching me like a Nigerian movie, also you have your notes, good. Mesoma, you have your notes, beautiful. Susan, you're watching me like, okay, Susan, you have your notes. Justice, you're watching me like a Nigerian movie, you have your notes. Good. Emmanuel, do you have your chin also? Do you have your notes? Ensure you have your notes where you're writing down things, right? Good. Makes sense. Have a note. Just let it show that you are in class. So now, let's now look at what I mean by precision and reading accuracy. I want you to follow me through this class, right? Let's look at. I see how I'm just taking it, just bulleting the point so that you can easily go back and read them, right? So the next point here is let's look at what we mean by precision and your reading accuracy. So now, what do we mean by precision and reading accuracy? Are you there? Precision / our reading accuracy. So now, when you talk about precision, now let's use our meter roof an example. I know some of us, the way we drink Gary, so you will see where there's so much consumption of Gary. In my school, we call it Toto. So how so much consumption of Toto can cause problem in the eyes and will affect your reading accuracy now. So now let's imagine that we have a ruler this way. Let's consider having a ruler this way. Sorry, I didn't achieve my goal. So let's imagine we have a ruler this way, and then there are tiny calibrations for each of them. Let's say that this place is my 0, right? This is my 0, and then let me have 1, 3, 4, 5, 6, 7, 8. Then let's have 1 here, right? We'll go again. So now it continues that way. I don't want to draw so much. This is in centimeter. So this ruler, and it continues just the same way that we can actually see right here on the screen. Are we together? So let's see whether we can replicate as much as possible. So now we have 3 right here. This is our 3. This is our 4, just that way. So 3, 4, and the rest of them. What am I trying to say? For your ruler, check each line here. You have. I'm just trying to make emphasis on something. Here is 1, right? Here is 2. Here is 3. Now, what will this each line be? Just like when you are plotting your graph. Remember when you are plotting graph that you have something like this. Please pay attention to this. There's a reason why I'm trying to go through this route now. I want everybody to follow through. So let's say we are plotting our graph, right? And we have that here is 1, here is 2, and you are not seeing your screen, sir. Is it the only person that is, if you know you can see my screen, can you signify? He said he's not seeing my screen. You are seeing my screen, right, Meso? Susan, you can see my screen. Okay, Emmanuel, can you try logging out and logging in again? I think it's your own internet. Thank you. So now, let's go back to this thing I'm trying to draw. So if you're measuring with ruler, the smallest calibration you are going to see in a ruler is 0.1. I don't know if this is making sense. The smallest calibration is 0.1 centimeter. And how did I get 0.1 centimeter? Remember when you are plotting graph, you are counting in 1, 2, 3, 4, 5, 6. We say that we are counting in what? In 1 unit. That we are counting in 1 unit. Can you see my screen now, Emmanuel? Also. Confirm you can see the screen now. So you are counting in 1 unit. When you are counting 1, 2, good, 3, 4, 5, and the rest of them. Then when you are counting in, what do you call it? When you are counting in twos, that is 2, 4, 6, 8, 10. Are you there? 12, 14, 16, 18, 20. You are counting in twos. How do I know what each line is? Here I skipped 10 lines before I counted one. I skipped another 10 lines before I counted two. To know what those tiny lines is, I'm going to do 1 divided by 10, which means the unit you are counting in divided by 10, which will give me 0.1. Now, if I'm counting in twos, let's say I'm counting in twos, and I have 2 here, 4, 6, and 8. If I want to know what each line on that very ruler, meter rule, represents, I'm going to do that 2. This is what you're going to be using in plotting graph. Divided by 10, that will give us 0.2. But what I'm trying to say, that for your meter rule, the lowest calibration we're going to have in a meter rule is what? 0.1. You cannot have any ruler that you can calibrate more than 0.1. Does it make sense? So that is what we mean by precision. Precision simply means the smallest division you can have in a measuring instrument. That is the meaning of precision. The smallest calibration, the smallest division that I can have in a particular measuring instrument. So for your meter rule, the smallest calibration is 0.1 centimeter. Or the smallest division for a meter rule is 0.1 centimeter. If you understand what I'm saying, can you just give me a thumbs up? If you don't understand, give me a thumbs down so that I can explain once again. If you understand what I just said, good. You can also give me a thumbs up. Susan understood. Mesoma understood. Justice, how far? Good, beautiful. So now that's the smallest calibration I can have for a meter rule, 0.1 centimeter. So calibration simply says what? Simply means one thing. It means what? The smallest what? Division on an instrument. So now permit me to move this our fine ruler. You see my ruler is fine, is that also? Is my ruler not fine? Nobody's talking. Finer than. All right. So let me quickly clean that ruler. Then I explain what precision is all about. So precision simply tells me the smallest what? The smallest division on an what? On an instrument. That's why you laughing. So now precision smallest division in brackets, you can call it calibration. Calibration in what? Or on. I'll go and learn English. Calibration on an instrument. Smallest calibration on an instrument. Then I used, for example, the example we considered. We said, can we quickly look at our meter rule? That was a fine example that we all considered. We used example, we considered our meter rule. We used meter rule as an example, right? So example was our meter rule. And I said for your meter rule, that the smallest calibration, remember I can have 5 here, I can have 6. So those tiny lines is going to be what? 1/10, which is equal to what? 0.1. So I have 1/10, which is equal to 0.1 centimeter. If you have your ruler, you can actually as well take any ruler around you. You're going to see that they are measured in centimeter, all those tiny, tiny ruler, right? So the smallest division we can have. It is when I start reading this thing, you understand better why I'm going through this stress. Smallest division is equal to 0.1 centimeter. But then there are two things you have to know in terms of measurements. You can always make reference to centimeter and millimeter. You know how physics can be, right? Sometimes I'm making reference to centimeter, you're making reference to millimeter. You can also make reference to your meter. That is how physics can be sometimes. So now, 0.1 centimeter or 1 millimeter. So how did the 1 millimeter come about? Remember back in primary school, though some of us didn't know what we were singing that time. We're just doing pound pyramid and make 1 parameter. Some of us didn't know the actual value that they were saying. It was when some of us entered secondary school that we said, oh, what we are singing is that 1 centimeter make 1 1 centimeter make 10 millimeter. All those things. 10 millimeter make, but back then you're just singing that song without actually knowing the meaning. So now, the conversion factor here is that 1 centimeter is equal to what? 10 millimeter. And that's why we'll have that very smallest division to be 0.1 centimeter or 1 millimeter, which means if I'm moving from centimeter to millimeter, you multiply. So we have the rule of thumb. The rule of thumb, centimeter to millimeter multiply by 10. Then millimeter to centimeter. And that rule of thumb someone taught me back then that if you are converting from something that is small to something that is big, you divide by the conversion factor. I repeat, if you are converting from something that is small to something that is big, you divide by the conversion factor. Example, if I want to convert millimeter, which is smaller than centimeter, the conversion factor is what you have here, 10. But from centimeter to millimeter, I'm going to multiply. Is that okay? So for a meter rule, we'll say that the precision of that meter rule, that the precision for meter rule is equal to 0.1 centimeter or 1 millimeter. So that's what we have for our precision for meter rule. Does it make sense now? Then, which means that each and every one of us can be given a particular length to measure, right? And when you measure that length, we're expecting a particular value from you, right? But you cannot measure past 0.1. That is the least amount. That is the smallest calibration that you can have in a meter rule. Anything above 0.1, that meter rule should be in heaven. But as long as we are on planet Earth, the smallest calibration or division we can have on a meter rule is 0.1 centimeter. Now, having said that, let's now look at what we mean by reading accuracy. Now, this reading accuracy now, when I give each and every one of us something here to measure, right? Let's say we have a particular length. Let's say we have a length this way. And then we'll have the value here to be 1, here to be 2, here to be 3. This is 0. And then we'll have all those tiny, tiny children as always. Now, let's assume that the value is here. Now, if I tell Chinonso now to come and measure, you know how it happens in school. Let's say we have a particular length. I called Chinonso, come and measure. Chinonso will look at it and be like, this is 2.4. Back then, during practical, we normally fight about it. I know some of us actually, you fought because of that measurement. Then the measure will come out and say what she's seeing is 2.4. Chinonso will say, Madam, you know, got it too much. This should be 2.5. Then Justice will be like, all of you guys are very crazy. It should be 2.6. Then Susan will now say she's the best student in the class. That what she's seeing is 2.8. Or let me say 2.43 because this is a big book. So now these are the different measurements. The same thing, we're measuring the same thing, but we're getting different measurement values. So now because of that, because of the tendencies we can have as human beings, and for some of us that have drank garri so much that we cannot see very well again, and for some persons that eat vegetable a lot that they can see, because of all of those things, physics said, okay, when we are measuring, we can actually give a range of value. That when we measure a particular length, we are giving you a range of value. So that range of value now means that if Susan measures her own, and her own is not within that range of value, that means she's very wrong. We can't even take her value. So, but let's now assume that Justice, Susan, and Eze, that all the measurement they did fell within a particular range. We can say, yes, if your answer is within this range, we agree. Remember during titration, when you did titration in chemistry, they will tell you this is the end point. For some of us that learned how to produce table without doing experiments, see as I'm casting myself. You can have a table without experiment. So they taught us back then, subtract some values from the endpoint, right? Subtract some values from the endpoint. Then you add it to get the rough. You guys are laughing, but that's the fact. We learned how to, without titration, we have table. So what we did then was to subtract values from the endpoint, right? Back from the endpoint and add values to the endpoint. With that, you have your rough titer. You know that's rough titer, first titer, second titer. You just the endpoint. They'll just be like, do you have the endpoint? Do you have the, you give me endpoint. I've done my table, church, I've dismissed. So now it's because the values are falling within a particular range. So now let's assume that the range of value, I want us to measure something, and that thing is here. Let's say we have this. So this is where I placed that object that I want us to measure. So someone will now draw a line this way, but different persons are seeing different things. Then as the teacher will now say, the range of this answer will be between 2.5 to 2.6. If your answer falls within this range, then you are correct. Are you seeing it now? So which means that the only person that is correct here, I can't remember the names I gave. This person is correct. This person is correct. But I remember I said that this one is for Susan. So Susan is wrong. Are you seeing it now? And I can remember I said this one is for who again? For Justice, and Justice is wrong. Right? So because they didn't fall within a particular value, that is what your reading accuracy is all about. And for ruler, if you're making use of a meter rule, there's a particular range that we're going to give you if you're measuring for meter rule. So for every meter rule, or not even meter rule, for every analog instrument, when I mean analog is the one you're measuring yourself. Digital is the one that makes use of technology to measure. But meter rule, you're using your eyes to measure. Analog. Are you seeing it now? So including some weighing balance when you climb the weight, right? I know that nobody here is that heavy that will weigh more than 2 bags of cement. 1 bag of cement is 50 kg. So now you can also use your eyes to weigh. That's measuring the length. You read it with your eyes, like the values. I mean, mechanically. So that's analog. So every analog instrument, that is exactly how we measure. We use that particular range for them. That is what we mean by your reading accuracy. So now what does reading accuracy entails? Based on this, my explanation, I simply said that, are we together? If we're together, give me a thumbs up, please. If we're together, a thumbs up. Beautiful, Chinonso. Beautiful, 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 beautiful measure. Well done, Grace Abraham. All right. Justice, it seems that you hear me after 5 minutes. Others will react. Your own reaction will come after 5 minutes. Does it take 5 minutes for you to hear me?
No.
Okay. Let me know whether it takes 5 minutes to get your end. It refers to how close the recorded value, are we there, is likely, are we there, to be to the true value, to be to the true value. How close it is to the true value. So now, and I said it is simply the range, that's what I said, it is simply the range, right, within which the value will be true. The true value lies. Are we together? So it is where that true value lies. And I've given you an example for that. So, and we have a formula for it. guys, it seems I left the meeting. Sorry. I'm trying to join back again. Just 3 minutes, please. How about now? Confirm you can see me and that you can confirm you can hear me rather, and that you can see my screen. All right, beautiful. I need to pin this one. Okay. I'm coming. I want to pin this. It looks as though it looks as though I need to pin this for everybody, and it looks as if how do we do this? I'm coming, guys. Let's pin so that people that are watching the recording can as well see. Okay, so we are trying to pin the screen so that you can visit your recording again, but it looks as if it's the other one that is pinned, and that's not a good one. That's not a good one. So, but let me continue. I hope we're going to fix that shortly. So I've talked about the range of values, and sorry about the break. So that uncertainty I spoke about, the uncertainty that might come from your eyes, or uncertainty that can come from the number of Gary you've drank, is simply plus or minus half of the smallest calibration. Or let's call it smallest division. So it means that uncertainty, in simple terms, is equal to plus or minus your precision divided by 2. Are we together, guys? And that is what we would regard as your reading accuracy, right? Yeah. So, Mr. Hillary, just help me pin that slide, please. Thank you, sir. So that's regarded as your uncertainty, and it is simply half of the precision. So for your meter rule, are we listening now? For your meter rule, and this is actually for analogous instruments. So NB holds for analog instrument, I mean to say. analog instruments. So which means that reading accuracy for meter rule will now be equal to what? 0.1 centimeter divided by 2. So science students, 0.1 divided by 2 will give us what? 0.1 divided by 2 will give us what? Nobody's talking. Hello? Can you hear me?
0.005.
0. Point what?
005.
0.005. So that will give us what? This is equal to what? According to justice, 0.005, not 0.005. Is it 0.0? Is that what you said? 0.005.
0.05, sir.
Okay, 0.05 centimeter. Are we on the same page, guys? So that's
Yes, sir.
that's the what? Yeah, but remember it's going to be plus or minus, please. Plus or minus. Are we there? Plus or minus. Let me confirm that division and let's be sure. Yeah, 0.05 centimeter. So or plus or minus. Now somebody converts 0.05 centimeter to millimeter for me based on what I taught you a few minutes ago. Convert 0.05 centimeter to millimeter very fast. What will it be?
0.5.
0.5. God bless you. So that will give us what? Plus or minus what? 0.5 millimeter. Right? So that is what the reading accuracy is. So reading accuracy is equal to what? Plus or minus 0.05 or plus or minus 0.55 millimeter. So what that simply entails is that we have a reading accuracy of this for your meter rule. So which means if we measure a particular value, please pay attention. Which means if I measure a particular value, what it entails, I will listen it. If I measure a particular value, let's say that I give us something to measure, and that thing is 36 millimeter. It means that I can give an accommodation that my range of value, it can be 36 minus 0.5 and 36 plus 0.5. So this is equal to what? 35.5 milliliter and 36.5 millimeter. Which means if I give us a length to measure, I'm expecting your answer to be within the range of 35.5 to what? 36.5. This is the range of value that we want your answer to fall inside. If your answer is not within this range, that means you are wrong for a meter rule. If it makes sense, give me a thumbs up. Do you understand what reading accuracy is now? Do you understand what precision means now? Exactly. So that's the range of value. So plus or minus 0.5 millimeter. So for me, I want to remember millimeter, 0.5 millimeter, 1 millimeter. Does it make sense? So precision for meter rule, 1 millimeter. Reading accuracy for meter rule, 0.5 millimeter. Right? I believe that we are all on the same page at this moment and that we can proceed. All right. So let's now, having said this, let's now go back and focus entirely on our meter rule, since I've spoken about your reading accuracy and I've spoken about other stuffs. So let's look at meter rule. Now, what are those things I want you to remember about your meter rule? If you have questions, you ask me. There are key things I want us to remember about our meter rule, and all of those things revolves around the important parameters that they ask us for JAMB, right? So the first thing I want you to remember about your meter rule is what they are used for, right? So let me take it this way. I like drawing diagrams like this so that I can always remember. Number one, used for measuring short distances. We use them for measuring short distances, right? The next thing I want you to know is that the precision, that's the smallest division in brackets. Smallest division is what? Tell me, what's this precision? The smallest division for meter rule. Tell me. Unmute yourself and tell me. Smallest division of a meter rule. You can type as well. Smallest division of a meter rule. It also says 0.1. 0.1 is not definite. 0.1 mangoes. 0.1 apple. 0.1 what?
Centimeter.
0.1 centimeter, right? So the precision is what? I want to use this so that your mind will be there. 0.1 centimeter or 1 millimeter. Does that make sense? So that's the precision. That's for your what? Your meter rule. And then let's go over to the reading accuracy now. So reading accuracy. Reading accuracy is what? Somebody give me the reading accuracy, men and brethren. Give me the reading accuracy, men and brethren.
0.05 centimeter, millimeter, or 0.5 centimeters.
It should be plus or minus 0.05. Am I correct? Centimeter. Or are we there? Is that not it?
It is it.
Yeah. Or plus or minus 0.5 millimeter. So just remember one of them so you don't get confused. For me, I like remembering millimeter. 1 millimeter. Do you understand? So 1 divided by 2. Remember that reading accuracy is simply, let me put it there so you don't cram. So reading accuracy is simply, don't cram anything. You are going to make mistake. Remember that this is equal to 1 millimeter divided by 2, plus or minus. So it's equal to what? Plus or minus 0.5 millimeter. Then you can now convert it to centimeter. Does it make sense? Does it make sense, guys? So just remember the millimeter. What did I say? Remember the millimeter. Then remember you can convert. Don't cram anything. So 1 millimeter is for the precision. Then 1 millimeter divided by 2 will give you 0.5 millimeter, plus or minus. Very important because you are going to subtract from the back and add to the front as well. Does that make sense, guys? All right. So that's for the meter rule. And that's what I want you to remember for your meter rule. So for meter rule, possible measurements. Possible measurement for your meter rule. Possible measurements. So now, for meter rule, you could have 30 millimeter. You could have 36 millimeter. You could have 478 millimeter. So now what do I mean by these possible values? What is this possible values trying to tell me, right? What I mean by possible values, remember that for that one, you're going to have, in terms of millimeter, it's going to be 0 decimal place. In terms of centimeter, it's going to be 1 decimal place. Now, if in JAMB, they can ask you, which of the following measurements can be obtained from a meter rule? Which of the following measurements can be obtained from a meter rule? So what does that imply? Now, which of the following can be obtained from a meter rule simply means that we can cross-check and check. So now, 0, what's the number of decimal place here? Number of decimal place here is 0. Is always a whole millimeter. Any millimeter, let me write this now. Notes. I know this might be a little bit confusing, and that's why I'm trying to say that. Are you there? Millimeter can only be whole. You cannot have anything other than a whole millimeter. That's when you are measuring with what? With ruler, right? So if you're working with a millimeter, you always have a whole number. That's what I mean. So if you're working with ruler, every distance or every length you measure with a meter rule will be a whole number in terms of the millimeter. Then if it is in centimeter, it's going to be one decimal place. That means you're going to have one digit after the decimal point. And that digit can be 0. You're going to have one digit after decimal point. So that's what it means. So which ones are wrong? So it's correct. You can have this. 30 is a whole number. If I'm making use of 30 millimeter, 36 is a whole number. 478 is a whole number. Now, in terms of centimeter, please pay attention, which is also equal to what? 30 divided by 10 is what? 30 divided by 10 is what? Is 3, right? So you're going to have something like 3.0. You're going to have 3.6. You're going to have 47.8. Observe something. You always have one decimal place. Remember, this is centimeter. It is when you start seeing jam quiz, you understand why I'm wasting so much time doing these things, especially with this side, because it's the basis of everything. So you have 0 here. Just keep checking this. Keep observing this. 6, 8. Linking towards one decimal place. Now, but you check this side for your decimals. If you check this side for your millimeter, there is no decimal, which means if I measure something and I have 30.0, you cannot have 30.0 millimeter. It's not possible. It could always be a whole number. So this is wrong. Does it make sense? Does it make sense? People will say clock it. If it makes sense, clock it. Does it make sense? If it makes sense, give me a thumbs up. So for meter rule, you can only measure whole millimeter. So this is what the possible measurement of a meter rule should look like. Because of what? Beautiful. Because of what? The precision is what? 1 millimeter. And for for centimeter, it is 0.1 centimeter. So if I look at a measurement, I will know whether this thing was measured in meter rule, because that's the highest, smallest calibration you can have for a meter rule. If we are good to go, give me a thumbs up so that I can move to the next one, which is your vernier caliper. I want to move to vernier caliper. If you are ready, let's move to vernier caliper. Yeah. Chinos, are you ready for vernier caliper? Chinos, are you ready for vernier caliper? Susan, you're putting a surprise emoji. What happened? Is it a mistake? Justice, are you okay for your vernier caliper? Justice, okay for vernier caliper? Okay. Justice is not responding, but I sure do hope he's still with us. Emmanuel said yes. Susan said yes. Okay. So these are the things I want you to remember for meter. And again, they can ask you the precaution you take when measuring with ruler. If you're measuring with a meter rule, ensure that your eyes is what? You have your eyes vertical, right? So some of those precautions you can take when you are measuring with, what do you call it? With your meter rule. Remember that time you did the experiment, they will tell you what are the precautions. So keep the eye vertically above the scale. Keep your eyes vertically above the scale to avoid error due to pararas. You can put it, I didn't write it down. Keep your eyes vertically above the scale to avoid error due to pararas. These are precautions you can, errors you can avoid. These are precautions. You can also avoid zero error reading. If you didn't start from 0 reading, you have to avoid those 0 error reading. You understand? So these are precautions to take when you're working with a meter rule. So that said, I want to move over to vernier caliper, right? As fast as we can. So let's look at vernier caliper. So for your vernier caliper is much more accurate than your meter rule. What did I say? Vernier caliper is much more accurate than your meter rule. So the distances, the length that meter rule cannot measure, your vernier caliper can measure it because it is it is accurate. So now we use vernier caliper. This thing is too big. So the first thing that we do is that we use vernier caliper to measure external diameter of a particular object. We can measure external diameter, you can measure internal diameter, you can measure the depth of something like the diameter of a metal rod, diameter of a tube, diameter of a rod. All of these things are what you can measure using the vernier caliper, and they always ask of that. So number one thing we use vernier caliper for is Measurement of external diameter. External diameter. Measurement of internal diameter. Measurement of depths. So it all falls down to what? E.g., you can measure diameter of a rod, of a metal rod. Are we there? You can measure diameter of a metal rod. Diameter of a metal rod. You can measure diameter of a cylindrical object. You can measure diameter of a pipe. You can measure diameter of a coin. It can measure diameter of a tube. All right, so these are the things you can actually measure using your vernier caliper. So some of those tiny, any small distance, any small length that your meter rule cannot measure, vernier caliper will give you that very beautiful accuracy. Is that okay? So that's what vernier caliper is going to give you. So the next thing I want to talk about is let's speak about the precision. Is that okay? So now the precision in brackets, the smallest calibration, or let's call it smallest division, the smallest division is going to be what? Look at how it is changing now. 0.1 millimeter. Are you seeing it now? The other one was 1 millimeter. It has the smallest calibration now. That means you can measure a smaller length, right? 0.1 millimeter, or convert to centimeter, my people, or what? Or convert to centimeter, my people, or what? Someone should convert millimeter, 0.1 millimeter to centimeter for me. 0.1 millimeter or
1.
0.1.
Is that true? You're moving.
Or 0.5
Susan, you said?
centimeter. Or
See what
0.1
I can hear now.
centimeter.
0.1, is that what you said?
Yes, sir.
No, now 0.1 divided by 10. If you're converting from millimeter to centimeter, you're dividing by 10. Justice, you said what?
I said 1.
No, now. You are converting from millimeter to centimeter. You divide by 10. 0.01, exactly. 0.01. Or 0.01 centimeter. You divide by 10. When we are converting, please take note of that. If you are converting from millimeter to centimeter, divide that value by 10. Then if you are moving from centimeter to millimeter, you multiply by 10 because millimeter is smaller. I repeat, millimeter is smaller. So when you are converting from a small one to a big one, you divide. And the conversion factor is 10. So 0.1 divided by 10. Do you understand it now, guys? Any question? Good. So that's for that. So now, I've spoken about the precision. So now, who can now give me the reading accuracy of this guy? Who can give me the reading accuracy now? From what I explained, what is the reading accuracy of a vernier caliper now? When I taught you about reading accuracy and uncertainty. Nobody is talking. What is the reading accuracy from what I explained to you?
2.24 centimeter.
I didn't hear you.
2.24 centimeter.
2 point what? Type on the chart, please.
Centimeter.
Type on the chart. Type on the chat so I can see what you're talking. Nothing is on the chart. Somebody should convert to millimeter. Sorry, I mean somebody should give me the reading accuracy now. What is the reading accuracy? Somebody should give us the reading accuracy. I'm waiting. Check your notes. How do you get the reading accuracy? I said that the reading accuracy is simply the precision divided by 2.
Zero 0.05.
0.05 what? Is it millimeter or centimeter? Which one did you divide by 2?
Millimeter.
Millimeter. So now the next thing you should remember is the reading accuracy now. So number 3, the reading accuracy is equal to what? I'm going to divide by 2, right? Is plus or minus 0.1 millimeter divided by 2, which is equal to what? 0.05 millimeter. Remember, plus or minus. That plus or minus is very important, right? Plus or minus, right? Right? So which means that the reading accuracy is simply what? Or let me write in blue so that we make emphasis with red. If you are confused on how Justice got that particular value, raise up your hand. So this will be plus or minus 0.1 millimeter divided by 2, which is equal to plus or minus 0.05 millimeter, right? So which means that our reading accuracy is simply what? The reading accuracy will now be equal to what? Plus or minus 0.505 millimeter. Or convert 0.5 millimeter to centimeter for me. Who is converting that to centimeter for me? Somebody should convert to centimeter for me. Anybody?
0.05. 0.0
plus or good. Plus or minus 0.005 centimeter. So it is not a big deal. So smallest division that you can measure 0.1 millimeter. That's the precision for vernier caliper. Then the precision for meter rule is what? Meter rule. Precision for meter rule. From what I explained. Precision for meter rule.
0.05 centimeter or 0.2 centimeter.
No, it's just 1 millimeter. 1 millimeter or 0.1 centimeter. That's the precision, right? The accuracy is what? Remember the precision. That's all I want. If you remember the precision, you can get accuracy because accuracy is precision divided by 2. Do you understand? Accuracy is plus or minus the precision divided by 2. So take note of all of these things. It's going to help you when we start reading all of these things. Any questions so far? Any questions so far? Any questions so far? Yeah. So what is confusing, Sha? Okay, let's review again. Let's review. My friend, look at what I'm saying, Susan. Right? I say for meter rule. First of all, know that for meter rule, the smallest division is the same thing as precision, is what? 1 millimeter. Do you understand? Then you convert the 1 millimeter to centimeter by dividing by 10. So 1 millimeter to centimeter is something as 0.1 centimeter. So if you can remember this one, you are good to go. If you can remember only this one, you are good to go because you can now convert. I think what is confusing you guys is you don't know how to convert. So conversion from millimeter to centimeter divided by 10. Does it make sense? So that's for meter rule, the smallest calibration of the precision. Now, for vernier caliper, the precision is what? 0.1 millimeter. Then convert to centimeter by dividing by 10. And that will give us what? 0.01 what? Centimeter. Then if you now ask me the accuracy of this one, what is the accuracy of this one? I will just do plus or minus that 1 millimeter divided by 2, which will give me 0.5 millimeter. Then you can convert to centimeter. So if you ask me about this one, it is simply the precision of this one, which is 0.1 millimeter divided by 2. It gives me a value of 0.05 millimeter. Then you can now convert to centimeter by dividing by 10. Are you still confused?
I'm okay now. Understand.
Eh? You understand it now, right? Good. So what I'm saying is, for me, millimeter goes. First one, 1 millimeter. Second one, 0.1 millimeter. Then I can convert to centimeter as the case demands. If we are all on the same page now, I want us to give me a thumbs up. If you don't understand, make reference so we can explain once again. Does that make sense now? Everybody, does that make sense?
Yes, sir.
Yeah, Justice has given me a thumbs up. Okay, good. So now, what are the possible readings now? Possible measurements from a vernier caliper. Possible measurements. So now, you can have for millimeter, is going to be 1 decimal place. For centimeter, it's going to be 2 decimal place. What do I mean? If I read the value, I'm free to have something like this. 30.00 millimeter. I know it is coming from, it's coming from what? Sorry. 1 decimal place. I can have this. I can have, right? So observe, what are you observing here? You're observing the number of decimal place, 1 decimal place. Observe, 1 decimal place. Observe, 1 decimal place. So when you have this kind of reading, 1 decimal place for millimeter, it means that you're making use of what? A vernier caliper. These are the measurements that can be obtained from a vernier caliper. Then convert those things accordingly. 30 divided by 10. See what I'm doing now? I'm converting all of those things to what? Centimeter, and see what will happen. Are we together, guys? So let me convert 30 divided by 10. 30.0 divided by 10. That will give me 3. Right? This is 3.00 millimeter. So now 26.1 divided by 10, I'm going to have 2.61 millimeter. Then I have 31.2 divided by 10. I'm dividing by 10. Look at my calculator, right? I'm dividing by 10. I didn't hear you. Sorry, centimeter. Thank you. You know, my teacher would tell us back then that he made that mistake to check whether we are following. So I made that mistake to know whether you are following. Right, centimeter. So observe what is happening here. Can you see what is happening here? We are having how many decimal places? We're having 2 decimal places for each of them. So these are the possible measurements that we can get from our what? Our vernier caliper. If it makes sense, give me a thumbs up so we can look at micro screw gauge and we'll see how we can read them. All right, beautiful. Susan, Susie, Susan. You know, so yeah, don't give me thumbs up if you don't understand, so that you can just follow others and give thumbs up. If you don't understand, talk. All right, so the next one is our micro screw gauge, right? Micro screw gauge. All right, I'm glad we're making progress. The next thing will now be how to read the vernier caliper, how to read the micro screw gauge. Then we're going to take a test. Let me see people who will do better, and that person, I'm going to give the person data, at least data worth 1,000 or 1,500. Yeah, worth of data for your class tomorrow. So ensure you are paying attention so that the data will be added onto you. All right, and as you do so, the Lord bless you. Let's look at micro screw gauge. So for your micro screw gauge, we use it to measure very small thickness and length. Is that okay? Very small what thicknesses or diameters. We use very what you want to measure something that is small, right? A thickness that is small or a diameter that is very small. We make use of your micro screw gauge, right? And this one is much more accurate than your vernier caliper. Is much more accurate than your meter rule. Like 100 times better than meter rule, and like 10 times better than your vernier caliper. So this one happens to be the most accurate, and you can use to measure very tiny length. So now, the first thing I want to talk about this, my friend, right, is that we can use it to what? Measure very small thickness, or diameters. Remember that Jambo will ask you which one can we use to measure. Have you seen that kind of question before? If you raise your hand up. What can we use to measure the thickness of a wire? What can we use to measure the diameter of a tiny rod? If you've seen that kind of JAMB question before, can you give me a thumbs up? For some of us have written JAMB before, right? You see question where they ask, what can I use to measure so and so? Give me a thumbs up. Yeah, you must have seen that kind of question. So if you want to measure very small thickness or diameter, we make use of what? Vernier caliper. So examples of such examples include, if you are measuring the diameter of a thin wire, right? You are measuring the thickness of a paper. You want to measure the thickness of a paper. You want to measure thickness of a sheet of paper, please. You want to measure diameter of a small metal rod. So all of these things are what you can measure with your what? Your micro screw gauge. Now, the next variable we should talk about, are we there? The next variable we should talk about, in summary, let me just write this. In summary, NB, if the object is very thin, right? It's very thin, just make use of what? Your micro screw gauge. All right. So that's for that, for the kind of things you can measure with it. So the next one is our precision as always. Let's talk about the precision of your micro screw gauge. Can I continue? So what's the precision? So for the micro screw gauge now, we're going to have an additional stuff. So the precision now, or the smallest calibration, is going to be 0.01 millimeter. Are you see how it's going now? Or 0.01 divided by 10 will give us what? Somebody. 0.01 divided by 10. Anybody saying anything? Remember, we're converting.
0.001.
1 centimeter. Are you seeing it now? So that's the precision, right? That's the smallest distance we can measure using your guy, right? That's the smallest we can measure right there. So now the next thing we have to talk about is your accuracy now, your reading accuracy. And I've told you how to obtain the reading accuracy just by dividing. That's 0.01 millimeter divided by 2, which will give us what? That's plus or minus, please. That'll give us 0.05 millimeter plus or minus, right? So which means you can now convert it. And when you convert, you eventually will have plus minus 0.05 0.005 millimeter, or are we on the same page, my guys? Or we have that 0.01 by 2, that'll give us 0.005. So 0.005 divided by 10 will give us additional 0, or 0.1235 centimeter. But for me, all I want to remember is the precision. If I remember the precision, I have no business with others. If I remember the precision, I have no business with others. So that is your what? Your reading what? Accuracy. Is that okay? So the next thing I want to talk about, that it is 10 times, right? Much more better. So it is 10 times more accurate.
Yeah.
Yes, my dear.
Okay, this reading accuracy of microscale gas. Is it that you divided that 0.0 millimeters by 2 to get 0.00, the last one 0.00 centimeter, 0.005 centimeter. Is it that you divided it by 2?
Yeah, anybody that understood that question should answer. Anyone that listened and understood the question should answer.
Let she come again. I know here.
Yeah, Susan, can you speak louder so that they can hear you?
I said the reading accuracy is that you divided that 0.01 millimeters by 2 to get 0.00005 centimeter.
No. Now, what I did is that you divide by 2 to get the reading accuracy. But now for you to now convert it to centimeter by dividing by 10. Do you understand? You have to convert. Do you understand? So why I'm doing it this way, because I want to base the stuff on millimeter. So you can always remember it's millimeter. First one, 1 millimeter. Second one, 0.1 millimeter. Third one, 0.01 millimeter divided by 2 will now give you the accuracy. Then you can now convert to centimeter. Does that make sense?
Okay. Yes, sir. Thank you, sir.
All right. All clear now, right? Men and brethren, all clear now, right? Good. Chinonso, are you here? Chinonso, have you left? Yeah, it seems you've left us and you're doing something else. We've not been hearing from you. If you are still with us, give us a thumbs up. Also, yes. Beautiful. So in summary, I want you to remember that one centimeter, because that's where you guys are struggling, will give you 10 millimeter. Do you understand? So if you want to now convert from centimeter to millimeter, multiply by 10, because centimeter is bigger. If you now want to convert from millimeter to centimeter, divide by 10. I want you to remember this, and that is it. Now, second thing I want you to remember is that your reading accuracy, don't cram it. Is your precision divided by 2. This reading accuracy can also be called the least possible error. What did I call it? The least what? Possible error. Should, in case you start seeing something about least possible error. Is that okay?
Yes, sir.
Yeah, so it's also called the least possible error. That's your reading accuracy. It can also be called the least what? Possible error. All right. So precision divided by 2. Then number 3, I want you to remember is that for meter rule, that the precision is equal 1 millimeter. For vernier caliper, precision, or the least count, precision is 0.1 millimeter. The 5 is your micro screw gauge. Somebody will now say, how come I'm not writing in centimeter? Because I don't have a problem with that. I can easily convert. And somebody will also ask me, how come I'm not writing about the reading accuracy? Because I don't have problem with, I can just divide by 2 to get the reading accuracy with my plus or minus. So this is plus or minus. Remember, plus or minus precision divided by 2. Precision is 0.01 millimeter. If I can remember this, I have no problem with others. Does that make sense, my people?
Yes, sir.
Yeah. All right. So that's it. Plus or minus divided by 2, precision by 2. So that is all I want you to remember. And then remember the conversion factor, that if I want to convert, I can easily divide by 10 if I'm converting from millimeter to centimeter, right? If I'm millimeter, I want to go centimeter, I just divide it by 10, right? So if I divided by 10 will give you 0.1 centimeter. But let me not put that so we don't have so much information on the slide. All right, so that's a summary of the thing I want you to always remember, right? So that said, let's go over to reading a vernier caliper. I want to go over to reading vernier caliper. Can I do that? All right, reading a vernier caliper. So permit me to quickly get an image of a vernier caliper so that it will be easier for us to walk through. Is that okay, guys? A thumbs up. Let me give us 5 minutes to process the information. 5 minutes to process the information you have so far. 5 minutes. So let's see, 5 minutes. All right. All right. So let me get images. Let me get questions. I want to get as many as possible. So sorry, I should have done this before the class, but you know how it can be sometimes. All right, I want to get as many as possible so that we can get our hands dirty, guys. I want to get as many as possible. So far so good. How is the class going, men and brethren? So far, how is the class going, people? I want somebody to say something. Say something, I'm giving up on you. So who is talking? Who is going first? Who is going first? Oh yeah, Susan, talk. Susan, talk. So from now, we shouldn't be begging you to come to class, right?
No, sir, you're not begging me.
No, you said?
You're not begging me. I have to come now.
Okay. Okay. Justice, how about you?
That is interesting, and I've learned something now.
Okay, beautiful. I like the fact that it's interesting and that you've learned something now. You're going to learn more in Jesus' name.
Amen.
Justice, you're not a Christian. Let me know so that I will be careful. Okay. Okay. You know, I have that freedom of religion, so I know when to stop saying amen in the class, so that we can accommodate other brethren, you know. As Emmanuel, how is it going? And meanwhile, we have scholarship openings for, if you have friends that you think they've written JAMB enough and you want them to enter school this year, you can tell them to actually apply. Is that okay? After the class, ask for the application form. That's if you have people that you want to bring into the class, please feel free, right, for them to apply so they can join us from next week. Is that okay, guys? Do you have someone that you want them to join? Anybody? Well done, bro. Anybody? Okay. I said, do you have anybody you want to bring in for the classes? Do well to bring the person, please. Is that okay? Yeah. So let's proceed now. Reading of vernier calipers. All right. So look at a vernier caliper on the screen. So how do we read? So for a vernier caliper, we have two scales, right? There are two scales to a vernier caliper. What did I say? There are what? There are two scales to a vernier caliper. I want to increase this vernier caliper a bit. There are two scales to a vernier caliper, right? We have the main scale and the vernier scale, right? The main scale is this one up. Are we together? While the down one is the vernier scale. So this guy here, this refers to the vernier scale, while this our guy here refers to the vernier scale. So how do you read a vernier scale? In reading a vernier caliper, I need to say the first step. Are we there, guys? What did I say? The step one is to read the main scale just before the zero of the vernier caliper. Read the main scale, right? Just before the zero of the vernier caliper. Read the main scale just before the zero of a vernier caliper. So now, step one. Follow these instructions. It's very interesting and very brief, right? So read the main scale. Now, who can show me where the zero of the vernier scale is now? So remember that this is the zero of the vernier scale, right? This is the zero of the vernier scale. Can you see it? So now the value, the one before, just before the zero of the vernier scale is this very value here. Can you see it? That's this value here. And now the main scale is always in centimeter. And it's important to know that this part is in millimeter. Do you understand? Main scale, you can write it down. Main scale, centimeter. Vernier scale, millimeter. Does it click? Main scale, centimeter. Vernier scale, millimeter. I didn't write it down. So put it down there, right? So read the main scale just before the zero of the vernier caliper. So here I have 10. This is 10 here. 10.1, 10.2, 10.3, 10.4, 10.5, 10.6, 10.7, 10.8, 10.9, and 11. So the value there is what? 10 point what, guys? 10.5. Is that also? Here is 10.5. Just before, sorry, I should be looking at this one. Just before the zero of the vernier caliper, please. I should be looking at this place. Does it make sense? That's where my eye should be and not the other way around. Are we on the same page, guys? Are we on the same page? So just before the zero of the vernier caliper, that is where I should look at. Are we there? Yeah, your hands are up. Go ahead, my friend.
Sir, is the class recording?
Yes, it's recorded. Yes. Let me
Okay,
check.
I'm asking because my phone is about to turn off.
Okay. It's recorded. It's recorded. You can always visit it. It's recorded. Sorry about that, my bro. That's Nigeria for you. There are things we can't help. Is that also? There are things we can't just help. Yeah, you're laughing, but that's the fact. There are some things we can't help. It just happens. And we don't have any choice than to follow through. All right, so please let me give us a few time. Write that thing down. Step one, read the main scale just before the zero of the vernier caliper. You can see the zero before the vernier caliper. Can you see that? The number you have before the zero of the vernier caliper. Remember that here is the vernier scale, not vernier caliper, please. This is the vernier scale. Why this is the main scale. this guy is always giving to us in centimeter, while the down part is given in millimeter. Does that make sense? All right, let's proceed. So the value here is what? 10.6. You can see that the value here, this is the one before the 0 here. So here is 10.6. So that said, I have that. I've read that step 1. So now the main scale, is equal 10.6 centimeter. Anybody that doesn't know how I got 10.6 centimeter? Anyone that doesn't know how I got 10.6 centimeter, please talk now or forever remain silent.
How did you get 10.6 centimeter?
Okay, good. Now look at here. Remember what I said, that the first thing you're going to do is to read the vernier, the main scale, and the main scale is the zero, the value you're going to see just before the 0 of the vernier scale, right? If you look at here, this is the vernier scale, and the 0 is here. This is where the 0 starts. So that line you're going to see before the 0 is your main scale. So read the value here. If you check, this is 10 here, and you have 10 lines, which means 10 divided by 1. Each line is 0.1, 0.1. So this would be 10.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 11. So here is 10.6. Does it make sense now? This very place. Here now is 10.6. Have you seen it?
Yes, I see it.
Good. So here is 10.6. So that place you are going to see before the 0. That's your main scale. So anytime they give you a vernier caliper, look at the main scale. That means the line you're going to see before you get the 0. Just before you get the 0, this is the 0. So that line there is your main scale. So read accordingly. They are counting 10, 11, and they have 10 lines, which means 10 divided by 1. Each line is going to be, 1 divided by 10. So each line is going to be 0.1, 0.2. That's what it simply means. So 10, 10.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 10.9, then 11. So that's how I got 10.6. Any other person? Any confusion? So now let's move to step 2 now. I hope all of us are okay now. Can I move to step 2, my brethren?
Yes, sir.
So now, good. So the next step is step 2. I'm going to find the point that aligns perfectly, right? Step 2. So I've calculated my value. So I'm to find the vernier division. That aligns perfectly with the main scale. Are we there now? So let's find that place that aligns perfectly with the main scale. So can you show me where aligns perfect? Okay, no, you cannot, because you cannot get the question. So find a place that aligns perfectly. There's a place you are going to see that the main scale crossed over to the vernier scale. There's a particular point you can see where it's crossed over. If you can see it, give me a thumbs up. Among all those lines, you are going to see a line that moved from the main scale to the vernier scale. Beautiful. And that's here. You can actually see that point here, right?
Yes, number 5.
Good. Can you see it, Susan?
Yes, sir.
All right. So we'll have this scale. There's something I want to do so that this thing will be more. So when you go through the slide, it will make more sense. So I'm coming. Let me see whether God will give me wisdom to do that. Meanwhile, wisdom is available, right? Okay, so let's see whether the Lord will grant me understanding so that you can easily read through this thing later on. You will not understand what I want to do, but when I do it, you understand better. So I want to move this guy a little bit down here. Then I want to copy this guy here. I want to copy this guy here so that it can come somewhere around here. Good. So that you can have read the main scale. So that my people, you see, so that when we read it, we'll have a value right here, and that is this place, and that gave us 10.6, right? So step 2 now says we should find the vernier division that aligns perfectly. So I want to do that now, right? So let's find the place that aligns. No, this is not the question we're working on. What happened? An enemy must have done that to me. No, let me bring it back again. Sorry about the back and front, guys. It's all for good. It's all for good. So let's have this at page. Yep. Copy. Then paste. All right. Great job, guys. So that we'll have it step by step. Delete. All right. So now we've actually marked the first step. I have read the main scale just before the 0 of the vernier caliper, 10.6. I have my main scale. So I want to apply my second step now, which is getting that very, and this is the only time I'm going to do this. The next time I'll be going straight up to solve them. So please follow through. Emmanuel, your hands are up. Emmanuel, your hands is up. Or your battery that's finally died. Okay, so let's locate that very point where there is a junction between them. So who else can see that very place where that thing crossed over? You can see it right here. So that's the place where it crossed over, right? And what's the corresponding value there? The corresponding value there is 5, right? So the reading there is 5, right?
Yes,
Good.
sir.
So vernier, good, thank you. So vernier reading is 5. So the vernier division, let's call it vernier division, is equal 5 millimeter, right? Then the step 3 now. Step 3. For step 3, we're going to do what? Multiply the vernier division by the precision. Have you seen where that precision is coming now? By the precision of a vernier caliper. So who can tell me, Susan, what am I going to multiply by? What is the precision of a vernier caliper? What will I multiply by? What will I multiply by? What is the division? What is the precision of a vernier caliper? 0.1 millimeter. God bless you. So that means that, and that will give me that the vernier reading now will be equal to the division, which is 5 millimeter, multiplied by 0.1 millimeter. Remember that this one is coming from your what? Remember, this is coming from what? Your vernier what? The precision. Is that not so? This is your precision. Then I'm going to have, what will it give you, please? Can you give me the value? Anyone that has calculator? So vernier reading is equal to 5 times 0.1. Anybody? Let me multiply my own calculator. Anybody? 5 times 0.1. That will give us 0.5. So I'm going to have 0.5 millimeter. Then your step 4, you're going to add them. Good, 0.5. So now step 4, add the main scale reading and vernier scale reading together. Is it difficult?
No, really, sir.
All right. I want to try it's difficult too. So remember that the main scale is what? 10.6, right? equal to 10.6 centimeter, right? Then
Yes.
vernier
Yes,
reading
sir.
is equal to
0.
0.5 millimeter. But you cannot add millimeter and centimeter together. Do you understand?
Okay.
So you cannot say 10.6 centimeter plus 0.5 millimeter is wrong. Do you see it now? So what am I going to do? I'm going to do what? I'm going to do what? I'm going to convert. Does it make sense? Because I can't do this, I'm going to convert. So I'm going to have
Yes.
10.
That is by
I'm
2,
going to
sir.
have by 2.
Okay.
Good. No, convert to, I prefer to convert to millimeter. So 0.5 millimeter, convert to centimeter rather. So divided by what? Divided by 10. So that will give us what?
Now
That will give us
give
what? 0.05. Does it make sense now? So total reading now is now equal to what? 10.6 plus what? 0.05. So when you add them together, it should give us something around 10.65. Is that okay?
Yes, sir.
So that will give us equal to 10.65. Does it make sense now? Centimeter. So that's the reading on that vernier scale. But if I'm doing this vernier scale, look at what I'm going to do. If it's from here, I will check what is the value here. What's the value for the main scale? Look at how I'm going to do my own without all these steps. What's the value for the main scale? 10.6. Is that also? So I will write 10.6. What is the value for the scale? I will write 5. But don't follow this pattern for now. I want to show you. Don't follow this pattern. I repeat, don't follow this pattern for now. Right? Don't follow it for now. That's for that actually. Okay, so when you check, you realize that we have 10.6 centimeter. And to tell you that you are correct, remember that vernier scale for vernier caliper is going to have 2 decimal places in terms of centimeter. Then also, it's going to have 2 decimals, 1 and 2, right? Or if I convert this thing to centimeter, millimeter, what will it be? Multiply by 10. Is that also? That will give us 106.5
Yes, sir.
millimeter. Observe again that you have 1 decimal place. Just be observing 1 decimal place. Are you seeing it now? 1 decimal place is always for what? It's always for what? Vernier calipers. Vernier caliper, the numbers will always be 1 decimal place. Then for centimeter, it's going to be 2 decimal place. I don't know if all these things are making sense at all. But that's how to read your vernier caliper. Any question on this? Any question on this? If you understand, give me a thumbs up. If we are cleared, give me a thumbs up. If you are cleared, can I get a thumbs up? Do you understand it?
Yes, sir.
Okay. If you are confused, let me know. Let me explain again. But in the absence of that, let's solve the next question. So look at this question now. They said, what is the correct reading in the following vernier scale, right? So let's do it together. What is the correct reading in the following vernier scale? So I'm going to look for that very figure just before the 0, right? So what's the figure? What's the number just before the 0? You can see the main scale reading is here already. So we'll have a value here, right? So that means that the main scale is equal to 10 point what? This is 20. This is, if it's 20, that means we're counting 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that place is 11. So this is what? 11 centimeter.
20.
Then there's a place that it's crossed. Let's look at the place that it's crossed. You can see that it was here. It's crossed here. Is that also? This is the crossing. So that place is 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that place is 3, right? That place is 3. So now the vernier scale is equal to 12, 13, 14, 15, 16, 17, 18, 19, 20. So vernier scale is what? The vernier scale is 3, 1, 2, 3. So that is 3 multiplied by 0.1, right? That will give us, I think that main scale is 12. Oh, thank you, bro. Thank you. You are very observant. That thing is 12. So that is 12 centimeter. Makes sense. Because it's written in 10. Yeah. 11, 12, 13, 14, 15, 16, 17, 18, 19. Thank you for that observation. Makes sense. You're on point. So now, this will give us equal to what? 0.3 millimeter. Is that not so? Is that not so, guys? 0.1 millimeter. So just before the 0. Oh, no, I'm not observing well. Oh. Look at that thing. What you're going to have just before, I'm looking at the wrong thing. Just before, please, attention, guys. You have to be very careful so you don't make mistakes in the exam hall. So let's look at the one. The one just before the 0 is this one. Is that not so? The one just before the 0 is this one. Do you agree? Give me a thumbs up now. The one just before the 0 for the vernier scale is that one I just touched now. Give me a thumbs up if you agree. Good. Emmanuel, also good. So that place, the scale there should be what? Is 13. Is that not so? It's 13. Yeah, here is 13, not 12. So I'm going to have 13 centimeter. Now the place where it crossed over to the other side is here. This is the crossing here, right? This is the crossing here. And the value there is what? 0, 1, 2. The value there is 2, right? So that means I'm going to have 2 there. So that means I will have vernier scale will now be 2 times by 0.1, which is equal to 0.2, right? Now, if you check, they didn't indicate whether this is, what do you call it? Okay, let's continue. Let's convert. 0.2 divided by 10 is what? Anybody will stay with me? Let's convert. 0.2 divided by 10 should give us 0.02, right?
Yes.
Right? But because if you check here, we have to be very careful here because they didn't tell us anything about the scale. Did they give any centimeter here? They didn't give us anything, right? So we have 2 right there. So we can just assume that the damper is also in centimeter as well, right? So let's add them together. So we have that the vernier scale, the total reading now, will now be equal to, they didn't give me any information, so I have just 13 there, equal to 13 plus 0.2, which is equal to 13.2. They didn't give us anything like scale. They didn't give us whether it's centimeter or whether it is millimeter, but we know that the conversion factor for here is 0.1. So we're going to assume that what we have there is millimeter. Am I confusing anybody? Are we clear on that?
Yes, sir.
Good. You know why? Because they didn't highlight. If they said that here is centimeter, there's one I will convert. But since nothing was mentioned, we're going to assume that here is millimeter. Do you understand? We will assume it's millimeter because this is our what? Remember that this figure here, 0.1, is usually our what? Our precision. Is that not so? This is our precision, right? Here is our precision. All right. The next one, they said, read the 2 vernier calipers and tell me the readings, right? So now, let's read the 2 vernier calipers and then we're going to tell them the readings. Is that okay? All right. So let's see. The first one is the number I'm going to see before the decimal point, before 0, right? And this is the number I can see before 0. So that will be 1.2. Do you agree with me? 1.2, guys. I agree. Give me a thumbs up. I agree. Give me a thumbs up. So that is 1.2. Sorry, 1.1. 1.1, 1.2, 1.3, 1.4. The one I'm seeing before the 0 point. This is my 0 mark. This is 0 mark. So this is what I'm seeing after the 0 mark. So I'm going with 1.1, right? That will give me a 1.1 right here, right? I'm taking this one just before the 0 reading, right? 1, 2, 3, 4. Good. So now let's look at the place where it crossed over. The place it crossed over was here. It's crossed over here. That's the value here. And that value there should be 4. Is that not so? 1, 2, 3, 4, 5. Yes. So let's add them together. I have main scale equal 1.1. The vernier scale equal 0.4. Is that not so? Equal to 4, right? So that will be 4 times by 0.1. And that will give us 4.4 millimeter. Remember that this guy is in centimeter, right? That being said, so total reading will now be equal to 1.1 plus, let's convert 4.4 divided by 10 because they indicated that here is in centimeter. So this will now give me 1.1 plus 4.4, 4 times 0.1, that's 0.4, sorry. This is 0.4 right here. Here is 0.4 here. So 0.4 divided by 10, that will give us 0.04. So that will give us 1.1 plus 0.04. That will give us 1.14 centimeter. Then you can convert to millimeter. Is that also? Or you do 1.14 times by 10. That is what? 11.4 millimeter. Anybody confused? Anybody confused?
Yes, sir.
So what's the confusion? What's the confusion?
Go back.
Okay, I should go over it. Okay, let's go over it again. Emmanuel, are you confused? Now, Susan, remember the first goal, right? The first thing I'm expected to do is that, let me check. I think Emmanuel is typing something out. Okay. So now the first step, if you are following, the first step right there is that I'm going to check the place after the 0, right? Just before the 0. The reading I have just before the 0 of my vernier scale. So if you check, this is the value there, just before my 0. This is 0. So just before my 0, that's what I have. Is that also? So what's the reading there? Remember that they've indicated that this one is in centimeter, right? This is in centimeter, but the other one, they didn't tell us the unit at all. So that's why we assume that it's in millimeter. So when they give us that place to be centimeter, right? So I'm going to have the reading here is 1.1. So what does it tell you? That the main scale is equal to 1.1 centimeter. Do you understand that one?
Yes, sir.
Good. So now the next step 2 said we should check for the place where there's an intersection between them, where it crosses over. That place where it crosses over. And if you observe, you see that this is where it crosses over. This is where it crosses over. And let's read it. Here is 0. So 1, 2, 3, 4. So the value here is going to be 4, right? So that means that my vernier scale will be what? That value 4 multiplied by my precision, 0.1 millimeter. Do you understand? Remember that this is your precision. Remember that this value here is your what? Is your precision. Right? And then when you multiply that number, what will it give you? When you multiply that number,
4 times 0.
Yeah, so if you multiply using your model, that will give us 4.4, right? So 0.4 rather. So vernier scale is equal to what? 0.4 millimeter. But you know you cannot add centimeter and millimeter together. That's the point. We cannot add millimeter and centimeter together, right? So that the reading now, are we together? So that the reading, that's in total, is going to be what? The other scale is 1.1 centimeter. So I'm going to have 1.1 centimeter plus, you cannot add millimeter and centimeter together. So I'm going to convert it 0.4 millimeter, right? I'm going to divide by 10. Do you understand? I'm dividing by 10 so I can convert it to centimeter. So that means this will now give me centimeter here. So this will now be equal to 1.1 plus 0.4 divided by this. Do you understand what I did there? Suzanne, do you understand?
Yes, sir.
This will give me 1.14 centimeter. Or if you want to convert to millimeter, right, you now multiply by 100, by 10 rather, or 11.4 millimeter. Does it make sense now? Do you know how I got 11.4 millimeter multiplying by 10? Does it make sense now? Are you sure? Are you still confused? Are you still
I'm trying to
confused?
do the
You're trying to do what?
calculation myself.
Okay, go ahead and calculate on your own. So in our next class, it will now be reading of micro screw gauge and then measurement of mass and proceed to vectors. Any question on that?
So yes, sir. I now get what
You
you're
now understand?
saying now.
Okay.
Yes,
Do you
sir.
understand it now? Do you understand it now?
Yes, sir.
Are you sure you understand everything now? Chinos, are you here? Give me a thumbs up if you are still with me. So you've seen what we did there. We have to find the main. Any question, Chinos? So find the main scale, find the vernier scale, right? So when you find the vernier scale, we have the value to be 4 multiplied by the precision. So vernier scale is 0.4 millimeter. Then the reading now will now be 1.1 plus. I cannot add centimeter and millimeter together. I have to convert that millimeter to centimeter so I can add them, or you can still bring them back to millimeter, right? Since they want our answer to be in millimeter. So that's it. Any question on that? And how do I move from centimeter to millimeter? I multiply by 10, remember, right? So what I did here was to do, please remember that what I did right there, here, was to do 1.14 centimeter times 10. That will now give me 11.4 millimeter. All right, so that's what I did right there. Yeah, so that's it. Any question? Any other thing? So remember that in summary, these are the things we learned in summary, right? That you have 1 centimeter here. You have the vernier caliper precision to be this. And I want to update my summary notes now. I want to update my summary notes to include the steps for your vernier caliper. If you have any question, feel free to ask me, guys. All right. So summary here, right? Summary, I've given you the precision. Now, the 6th one is reading a vernier caliper. So if you are reading a vernier caliper, what are the things I want you to do while reading a vernier caliper? Reading a vernier caliper, I said that my first step, are you there? My first step is to read the main scale, right? So read the main scale. Now, the second step is that I should find hope you guys have not left me alone here. Huh? Hello, are you still me?
Yes, sir.
Okay. And then finally, add both values. All right, so these are the things we learned today. Is that not so? So always make reference to this, right? Auto summary for all you need. All right, guys, so that's it. We are all good, right?
Yes, sir.
Yeah, so in our next class, we're going to look at what you should be expecting in the next class. Then solve questions, yeah? So next class, we'll look at reading micro screw gauge.
That's micrometer physics, right?
Yeah. Then the next one, yeah, micrometer screw gauge, don't mind me. Micrometer screw gauge. Then the next one is measurements of weight / mass. Watch on your dashboard.
The mass and weight.
Then, yeah, mass and weight. Then the next one will look at vectors. That's scalar quantities. All right, so that's it. You're going to learn how to read micrometer screw gauge, not micro screw gauge. Don't mind me. My head can twist sometimes. All right, so so that's it. Watch your videos. I wanted us to do a quiz, but then the time is passed already. Like we don't have time again. But I'm going to upload the assignment on your dashboard. So please do well to do that. And we're going to have a quiz in our next class. Like I said, anybody that wins will have 2,000 naira from me for data. Yeah. So go and read your notes. Learn how to do the micro screw gauge. I wish you all the best. All right, guys. Peace out, guys. All right, peace out, guys. Yeah, Kule is here. I think I should save my section. Welcome. Yeah, you're welcome. So you can have it. Mr. Kunle, you can give them a short 5 minutes break so they can rest a bit. Then you continue. We didn't start on time. So I'm saving the recording now, and then you can start off later on.
All right, no problem.
All right.